In this video, we're going to learn how to determine the self-weight of our beam. Do we know that knowing the self-weight of our structural element will help the designer, the structural engineer, during his design for beam, the columns, and our slab? Especially, like for example, our slab. For the designer to design the columns that will carry our slab, he will first of all determine the self-weight of the slab, considering the dead load and the live load on this slab. So let us dive into this calculation. Looking at this beam, we have the density of our ROCC to be 2,500 kg per meter cube. This is called reinforcement concrete. It's called reinforcement concrete because we have the reinforcement inside of this beam. Look at it. This is our reinforcement. Remember, we also have PCC, that is plain cement concrete. It's different from this ROCC. So let's see how we can determine the weight of this beam, knowing that the length of this beam is 6.2, the width is 0.23, and the thickness is 0.23. So what you need to do is this. Remember that density itself is mass over volume. So first of all, let's know what is the volume of this. The volume of this beam. Volume is this. Which is equals to, the length is 6.2 by the breadth is 0.23, the thickness is 0.23. So let's multiply at this. We'll have 0.34 meter cube. So this is the volume of our beam. So having known the volume, the next thing for us to determine is the self-weight. The self-weight, which is equals to the mass of this beam, which is equals to what? Density multiplied by what? Volume. What is the density of this ROCC? We have 2,500 kilogram per meter cube multiplied by the volume, 0.34 meter cube. This will go with this. What is left is this. This multiplied by this. We have 850 kilogram. So this 850 eventually becomes the self-weight of this beam. Remember